Hey guys, back with you guys again. Today we're going to talk about matter, all right? And so we're going to break it down to the smallest pieces of matter, which is called an atom. So remember in class, okay, we talked about matter, and matter can be in two forms, all right? The two forms are living and non-living. All right, both are important because we need non-living matter to stay alive and so forth. But both of these guys, what are these guys made out of? These guys are made out of things called molecules. Molecules are made up of atoms. So if you take atoms together, you put molecules together, you can get either non-living or living matter. All right, so it's very important that you understand this concept. So in class, what we did is we talked about, we're using models, okay, to demonstrate what molecules really are. So the first piece of the model that I'd like to review with you is this white marble. Remember, this white marble represents a hydrogen atom. All right, and so when you think about this guy, what you really want to think about is want to think about this actually being a proton and an electron, and then the electron is moving all around, and so that's the hydrogen atom. Okay, the other atom that we're going to talk about is the oxygen atom. The oxygen atom, all right, so O for oxygen, right? Okay, so the red marble represents an oxygen atom. All right, this atom is much bigger than hydrogen because it has 8 protons, okay, and 8 electrons, okay, going around the nucleus. All right, then we have another important atom, which is the blue one, okay, which represents the nitrogen atom. All right, and nitrogen atom has 7 protons and 7 electrons running around it, and there's some neutrons in there as well, but we're not going to worry about that. You're going to go ahead and talk about that in chemistry class. And then finally, okay, we have the most amazing atom of all, okay, which is the black marble, represented by the black marble, which is the carbon atom, right? And the carbon atom is amazing. It has 6 protons and it has 6 electrons, okay, going all about the nucleus. And so you guys have to remember that when we're building and putting models together, all right, we're going to be using these marbles, which represent single atoms. All right, so now let's talk about molecules. All right, guys, now in order for you to understand why molecules form, you have to understand something about the atoms. Okay, so here's our hydrogen atom that's represented by this white marble. Hydrogen has 1 electron, and actually it's missing 1 electron. So I'm gonna just draw like a sad face, like it's missing, it's not there. Okay, oxygen actually is missing 2 electrons because it wants to fulfill, like have electrons all over it, so it's actually missing 2. Okay, nitrogen is missing 3 electrons. Okay, and because it's missing those 3 electrons, all right, think of it like it's sad, like the atom is not, it's not where it wants to be, right? This one, carbon, is actually missing 4 electrons. They're MIA, right? And so what ends up happening is hydrogen is going to want to bond or connect with another atom so that it can get back its missing electron. All right, oxygen is it needs 2 electrons, so it's missing 2 electrons, so it's actually going to connect with 2 other atoms to get those 2 electrons. Nitrogen is missing 3 electrons, okay, and so it's going to bond or connect with 3 other atoms to get 3 electrons that it's missing. And finally, carbon is missing 4 electrons, so that's why carbon is always going to connect or bond to 4 other atoms to get those 4 electrons that it's missing. An easy way to remember it is just remember of HONC. Hydrogen is the first letter, oxygen is the second letter, nitrogen is the third letter, and carbon is the fourth letter in the word. So that's easy way of remembering that hydrogen is missing 1 electron, oxygen is missing 2 electrons, nitrogen is missing 3 electrons, and carbon is missing 4 electrons. And that's why it's going to bond with 1 atom. That's why it's going to bond with 2 atoms. That's why nitrogen is going to bond with 3 atoms. This is why carbon is going to bond with 4 atoms. Because by bonding with 4 other atoms, that's how it gets its 4 missing electrons. By nitrogen bonds with 3 other atoms, okay, because that's how it's going to get its 3 missing electrons. Oxygen is going to bond with 2 other atoms because that's how it's going to get its 2 electrons that it's missing. And hydrogen is missing 1 electron, and that's why it's only going to bond with 1 other atom. All right? Okay, hope this helps. Now we're ready to talk about a molecule. All right, guys. Okay, so now let's talk about molecules. All right, so the first molecule we're going to talk about is the hydrogen gas molecule. All right, now what is the formula for this molecule? Okay, it's very important that you understand formulas. All right, so the formula of this molecule is H2. That means that the molecule has 2 hydrogen atoms. All right, now you are responsible for knowing how to reading this formula. All right, now also I will give you the structure for the molecules. So the structure of this molecule, all right, is really simple. So you actually have 1 hydrogen atom. Okay, it only has 1 hole because it's missing 1 electron, and then this one's missing 1 electron. And so when they join together like this, they're both sharing electrons. All right, and so the actual structure of this molecule is 1 hydrogen atom connected to another hydrogen atom, and this bond, this line, right, is represented as here, and that is called a covalent bond. All right, and this is what holds the 2 atoms together. If we had to show it in electron style, all right, and it actually looks something like this. Okay, notice that hydrogen now has 2 electrons, and this hydrogen has 2 electrons because they're actually sharing each other's electrons. And this sharing is what holds the 2 atoms together. And we call this a molecule. This is 1 molecule, all right, okay, that has 2 atoms. So it's very important that you understand the difference between molecules and atoms. Okay, 1 molecule with 2 atoms. Right, that's what that means. All right, which 2? Well, obviously hydrogen atoms. All right, guys, now let's talk about the methane molecule. And methane looks like this. The structure is like that. Okay, it has a carbon in the middle, and then it has 4 hydrogen atoms attached or bonded to that carbon. All right, and notice carbon is bonded to 4 things because it's missing 4 electrons, and hydrogen is bonded to only 1 thing because it's only missing 1 electron. All right, so what is the formula for this molecule? All right, well, C, there's 1 carbon, and there's 1, 2, 3, 4 hydrogens, so that's why we put the 4 subscript on the bottom. All right, now go ahead and take a little bit of time to build this molecule. All right, guys, if you did it correctly, your molecule will look like this: a carbon atom in the center and 4 hydrogen atoms connected to this carbon atom, represented by the black marble. Now, it's very important that you understand that this model, all right, is represented by this structure, and this is the formula for this molecule. Now, it's very important, again, remember this is 1 molecule, all right, and it has 5 atoms. One molecule, 5 atoms. What are the 5 atoms? 1 carbon and 4 hydrogen. That is what I say it has 5 atoms. All right, now, what if I had 2 of these molecules? How would the formula change? All right, so let's talk about that a little bit. All you have to do is make sure that you write a 2 in front of the whole thing. This is telling the reader or yourself or whoever you're trying to communicate to that there are 2 molecules of CH4. All right? A common mistake is people would go ahead and write this, C2H8 for this. And that is not the same thing. This actually, you're saying that there's 1 molecule, okay, where carbons would be connected, right? And then remember, carbon can only bond to 4 things. So it's actually impossible to have 2 carbons with 8 hydrogens. It's impossible because it only can bond for 4 things. So this is wrong. All right, you cannot just add up, all right, the things here, the atoms, okay? You have to remember each one of this is a molecule because there's 2. We write a 2, all right, and that's telling us that we have 2 of these molecules. All right, hope that helps. Now I want to take a look at the oxygen gas molecule. Oxygen gas has 2 oxygen atoms. All right, so here are our oxygen atoms. Now notice it has 2 holes. Each atom has 2 holes because it needs 2 electrons. So if we use our small connectors to build this, right, okay, then we're going to have an empty hole, and we don't want that because that means that the 2 atoms are missing electrons. So in this case, we're going to need these flexible connectors, and these flexible connectors allow us to make a double bond. Got it? So O2 actually looks like this. The way we write the structure is we have an oxygen atom and it's bonded twice to the other oxygen atom. This is called a double covalent bond. And that's why now our formula here, we have 1 molecule, right? 1 molecule, right? Because there's no number here. And it has 2 atoms, right? 2 atoms. But what if I have 4 of them? This is what oxygen gas looks like in the air. It just, all these little molecules are in the air and you're breathing these molecules in. So now how does this change? Okay, now we have 1, 2, 3, 4 molecules. All together we have 2, 4, 6, 8 atoms, right? But that's not how we're gonna write it. All we gotta do over here is we have 4 molecules, so we write a big 4, and that's why all the oxygen atoms are accounted for, because we have 4 O2s, and in each molecule there's 2 oxygen atoms, so 4 O2 molecules. All right, so remember, when we're writing the number as a subscript, that tells you how many atoms are in the molecule, and the number in the front tells you how many molecules of that type we have. All right. All right, guys, now what we want to do is we want to talk about a different molecule, okay, that's super important, just like O2 was. And this is called carbon di, meaning 2, oxide. So carbon dioxide. See, carbon with 2 oxygens, right? So now what I want you to do is I want you to take a little bit of time and build this molecule. So pause the video and build this molecule. Now, if you built it correctly, it looks something like this. Remember, these double lines that look like equal signs, Those are double covalent bonds. All right, so that's each line, okay, is actually an electron that the atoms are sharing. And notice carbon this way is getting the 4 electrons that it's missing. Oxygen is getting the 2 electrons that it's missing, and that's why this molecule forms, because the atoms are more stable. They're more happy that way, right? Now, once this molecule is formed, all right, now what would be the formula, right? Now, okay, there's only 1 carbon, so we write that. And there's 2 oxygens. So remember, because both of the oxygens are in the same molecule, we write a 2 subscript like this. And that is the formula for this beautiful molecule right here called carbon dioxide. This is the molecule that we breathe out, and this is the molecule that plants need to stay alive. We produce it for plants. And so without us, plants would die because they wouldn't have this molecule. Now, what if we had 4 CO2s? How would the formula change, right? Well, we definitely remember there are 4 different ones, so all we got to do is write a 4 in front of the whole thing, and that tells us that we have 4 CO2s. Okay, never write the formula like this. Don't ever do this, because it's actually impossible. All right, this, if you wrote it like this, then you're saying that it's only 1 molecule, and this is not the same thing as that. All right, so this is correct, this is wrong. All right, okay, hopefully this helps. See you next time. All right, guys, now let's talk about the water molecule. Okay, water, as most of you guys know, okay, is H2O. Why is it H2O? Because the molecule has 1, 2 hydrogen atoms, and both of these hydrogen atoms are connected or bonded to the oxygen with a covalent bond, a single covalent bond. Notice oxygen, okay, still has 2 connections because it needs 2 electrons. Hydrogen, only 1 bond because it only needs 1 electron. Now go ahead, pause it, this video, and go ahead and build a water molecule. If you did it correctly, your molecule looks like this. Notice oxygen atom, 2 hydrogen atoms. Now the formula, H2O. Notice we have 1 molecule that has 3 atoms. Okay, 2 plus 1 oxygen equals the 3 atoms that I'm referring to. But now, what if we had this? Because water is actually billions and billions of these types of molecules. All right, and now what is the formula now? Okay, we actually have 1, 2, 3, 4, 5, 6 water molecules. So therefore, we would change the formula by adding a 6 in front of the H2O. That tells us that we have 12. 6 times 2 is 12 hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And 6 oxygen atoms. Boom, 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 boom. There it is. And now every atom is accounted for in our formula, but we are very clearly stating that there are 6 different H2O molecules. In class, make sure that you do not do this. Okay? Do not do this. Don't write it like this. This would be wrong because this implies that you have 1 molecule and all the atoms are bonded together. And is that the case? No, they're individual molecules. Okay, it's probably impossible to build this molecule here. If you'd like to try, go ahead and pause the video and see if you can do it. But remember, this is the correct formula. This is something completely different. All right? All right, guys. Okay, now what I want to talk about is the molecule that's called carbonic acid. So, carbonic acid molecule. All right, so notice this carbonic acid molecule, okay, has 1 carbon atom, 2 hydrogen atoms. So we're going to write H2, 1, 2. C only has one C, and it has 3 oxygen atoms, so I would go ahead. Okay, and that is the formula for carbonic acid. This molecule is super, super important in our cells. You will read about this molecule in section 4 of our book. But now go ahead and take a little bit of time, okay, to pause the video and build carbonic acid. Now that your carbonic acid is complete, notice you should have a double bond here, okay, and it's represented by this double line. So this is a double bond. And when you're reading your diagrams, these equal signs really do make a difference. So if you see a double bond like that, okay, in your models, then you better see that in your structure. Okay, it has a covalent bond there, a covalent bond there, so that would be these. Okay, and then here I didn't draw the line, but it's implied. Okay, sometimes in books, scientists don't always draw all the lines, but there's no such thing as an OH atom. This is actually an oxygen that's bonded to a hydrogen atom. So if you build it correctly, this is what you should have. Now, what if I had 2 or 3 or maybe 4, okay, of these molecules? What would the formula be? Now here I have 2 carbonic acid molecules, all right? So how would I modify my formula to express this or to communicate this on paper? Well, remember, because they're 2 different molecules, we just simply write a 2 at the front of our formula, and that tells us, okay, that there in these 2 molecules, if you add up all the atoms, there's 2 times 2, there's 4 hydrogen. So there's 1, 2, 3, 4. So that's how we know all our hydrogens are accounted for. C, okay, there's 2 C's, 1, 2, and 2 times 3, that means there's 6 oxygens total, 1, 2, 3, 4, 5, 6. Now all our atoms are accounted for, but because we put the 2 in the front, that tells the person that we're communicating with that there are 2 distinct molecules, okay? And each molecule has these many atoms in it. All right, so hopefully this helps. Okay, make sure you know the difference between the structure, that's what a molecule looks like, and the formula, okay, and how it changes when there's multiple molecules, okay, in our exams. Okay, so make sure that you know the difference. Okay, see you next time. Hope this helped.